Agile project velocity. A velocity chart in Agile is a simple, powerful tool that helps teams visualize how much work is completed over a number of sprints. It's primarily used in Scrum, but also applies to other Agile methodologies that use time-boxed iterations. A velocity chart displays sprints on the x-axis, time, story points or effort units on the y-axis. For each sprint, it typically shows two bars: planned velocity, total story points committed to at the start of the sprint; actual velocity, story points completed by the end of the sprint. The table shows sprints 1 to 4, what is committed and what was actually planned. A burn down chart represents the ideal burn down line, which is the blue line. The actual burn down line is the green line. Then there's remaining work and time, shown on the different axes. The scope is fixed, shows remaining work. A burn down chart in an Agile project visually represents the progress of work over time. Its main components include the x-axis, time. The axis typically represents the time duration of the sprint or project. It could be divided into days, weeks, or other relevant time intervals. Y-axis, work remaining. This axis represents the amount of work remaining. This can be measured in story points, hours, tasks, or any other unit used to estimate work. Ideal burn down line, a straight line that slopes downward from the total amount of work at the start of the sprint to zero at the sprint's end. It represents the ideal pace of work completion. Actual burn down line, a line that shows the actual amount of work remaining over time. This line fluctuates based on the team's progress and reflects the reality of work completed. Completed work. The points where the actual burn down line drops indicate work that has been completed. This helps visualize progress toward the sprint goal. Sprint goal or milestone marker. Some burn down charts include markers to indicate specific goals, milestones, or sprint boundaries, helping to contextualize progress. Anomalies or deviations. Any significant deviations from the ideal burn down line, such as sudden increases or plateaus, can indicate issues like scope changes, underestimated work, or blockers. These components help track progress, identify potential risks or issues early, and adjust efforts to ensure the timely delivery of work. Burn up chart. The blue line is the baseline, the green line is actual work, slows upward, you have a time and work units. Scope may change, shows progress and scope. A burn-up chart is a project management tool used to track work completed versus the total amount of work over time. It's often used in Agile and Scrum methodologies to visualize progress toward a goal. The key components of a burn-up chart include the x-axis, horizontal axis, which is time. Usually represents time such as iterations, sprints, days, weeks, shows the timeline of the project. Y-axis, vertical axis, work units, represents the amount of work typically in story points, hours, tasks, number of features. Total work line or scope line, a horizontal or sloped line showing the total scope of the project. May change over time if scope is added or removed. In Agile, scope creep or adjustment. Shows the goal to be reached. Completed work line or progress line. A rising line that shows how much work has been completed at each point in time. Should trend upward toward the total work line. Optional, forecast, trend line. A projection of when the total work might be completed based on current velocity. Useful for predicting project completion. Optional, scope change indicators, markers or adjustments to the scope line to indicate when scope has increased or decreased. The table is a summary of the components of a burn-up chart. Column 1, component. Column 2, description. X-axis, time. Time intervals, days, sprints, weeks. Y-axis, work units. Units of work. Story points, tasks, hours. Total work line shows total scope or goal. Completed work line shows progress toward the goal. Forecast line, optional prediction of completion date. Scope changes, optional adjustments if the scope increases or decreases. A visual comparison of the burn down chart and burn up chart. Column 1, feature. Column 2, burn down chart. Column 3, burn up chart. Focus, work remaining, work completed. Line movement is down, up for work completed. Scope changes are not easily visible. Epic burn down chart. What it shows. Progress toward completing all the stories within a single epic. Tracks how much work remains in the epic over time, usually per sprint. How's it structured? X-axis equals time, sprints or dates. Y-axis equals total effort remaining, story points or issues. Why it's useful. Helps track if the epic is on schedule. Shows if scope is creeping when new stories are added mid-epic. Useful for product owners and stakeholders to understand progress on big features. Release burn down chart shows progress toward completing all work planned for a release. Includes multiple epics or stories from across the backlog. The structure, X-axis, sprints or calendar time leading up to release. Y-axis, remaining work, story points, tasks or issues. Usefulness, forecasts whether work is on track to meet the release date. Identifies if too much work remains for the time left. Encourages conversation around scope cuts, team velocity, or release date changes. The chart shows epic and release burn down. Column 1, sprint. Column 2, work remaining, story points. Column 1 runs from sprint 1 to sprint 7. Column 2 runs from 120 work remaining or story points to 0, which would then be the release or epic complete. Visually, this is a downward sloping line burned down towards 0. Tips. Keep the stories well sized and estimated for accurate charts. Watch for scope creep. Adding work increases total effort. Use alongside velocity trends for better forecasting. Wrap up. Project velocity acts as a retrospective metric that measures the amount of work, story points completed per sprint, enabling accurate forecasting of release dates, realistic sprint planning, and sustainable team pacing. This aids to understand capacity, identify bottlenecks, and align stakeholder expectations.